Hello friends, welcome to Susan and John MathTube. This is lesson number 3 in the examination preparation series for Engineering Mathematics 3. That is for the second year first part. And in this video, we will learn a little bit more about line integrals. That is exactly 2 important problems in line integrals. And then we move on to the next topic, that is scalar potential. And as always, the 5 important points to make the video lessons effective. And point number 1 is the most important point, that is, make sure you're ready with a pen and a paper so that you can work out all the problems along with us. And that makes you very confident. And point number 3, you know. And point number 4, it's equally important. Once you finish watching these videos, you must work out a lot of questions from any book you like. And finally, to test yourself, take the past paper questions and try to work out and check whether you're able to do the questions by yourself. That's it. So let's start with part number 3. Okay, so please write the question. Find the work done. So work done means we have to calculate integral over C f dot dr. And f is given to be x square plus y square times I minus 2xy times j. And the path is given, it's given to be a rectangle in the xy plane. It's given to be a rectangle in the xy plane, and it's given by x equal to 0, y equal to 0, x is equal to a, y is equal to b, where a and b are positive. Okay, this is a series of video lessons. So if you have not watched lesson 1 and lesson 2, please pause the video right now and start with lesson number 1. Okay, so let's start. So we are asked to find the work done, and work done is nothing but integral over the path f dot dr. So we are ready with the integral. Now the next thing, the path. It's a rectangle. Okay, now I think you know what is x equal to 0. X equal to 0 represents the y-axis. If you look at any coordinate in the y-axis, it will be 0 comma something, 0 comma something, 0 comma something. Hence the name x equal to 0 for y-axis. Similarly, y equal to 0 is the x-axis, and x equal to a is a line parallel to the y-axis, but it will pass through the point x equal to a. And y equal to b is a line parallel to the x-axis, and finally we end up with a rectangle. So the first thing we need is a diagram. So let's start. So we have our rectangle, and this is our x-axis, that is x equal to 0, and then this is a line parallel to the y-axis, and that is x is equal to a, and this is a line parallel to the x-axis, so this is y equal to b, and finally our origin. So we have the rectangle OABC. So this is our path. So look at this. C means OA plus AB plus BC plus CO. Now let's analyze one by one. And remember, you're going to integrate 4 times. You're going to integrate how many times? 4 times. Okay, before we start, let's find f dot dr. So we have f dot dr equal to x square plus y square times dx minus 2xy times dy. And let's put it in a box. We have to use this again and again and again and again 4 times. Now let's calculate the limits. Now look at this. OA is the x-axis, and x-axis means y equal to 0. So I'm going to write the path y equal to 0, and that means dy equal to 0. And that implies our f dot dr, this whole part will vanish, and y will also vanish. So f dot dr will be x square dx. So f dot dr is equal to how much? X square into dx. And one more thing, x varies from 0 to a, and there is no y, so you don't have to worry about y. So that's it for OA. Now for AB. Okay, now look at the movement. We move in anti-clockwise direction, counterclockwise direction. AB means there is no change in x. X is fixed at A. So AB is actually the path x equal to A. But when you take the differential, when you take dx, you'll get 0. And that implies f dot dr will be equal to, look at this, x equal to a and dx equal to 0. So this whole part will vanish, and instead of x we have to write a. So we get minus 2ay. Look at this. This part will vanish because dx is 0 and x is nothing but a. So you get 2ay dy. And there is no change in x. X is fixed. But y moves from 0 to b. This is the line y equal to b. So y moves here from 0 to b. Okay, now the third integral, bc. Remember, we have to move in the anti-clockwise direction. Now the path is y is equal to b. So when you take the differential, we get 0. And that implies our f dot dr is equal to, so dy is 0. So the second part will vanish. And here we have x square plus b square. So that will be x square plus b square into dx. And of course the limit is from, look at this, x is a here. At this point x is a and a to 0. So x varies from a to 0. And finally our CO. CO is the y-axis, and the y-axis means x is equal to 0. So dx will be equal to 0. And that implies f dot dr. We have to put x equal to 0, dx equal to 0. So when x equal to 0 and dx equal to 0, this whole thing will vanish. And when x equal to 0, this will vanish. So our function is nothing but 0. And when you integrate, definite integrals, not indefinite integrals, when you integrate 0, the answer will be 0, provided it's a definite integral. So you don't have to worry about the last part. Now it's time to integrate. So integral f dot dr will be integral over OA plus integral AB plus integral BC plus integral CO. Of course, the last one will vanish because f dot dr is 0. And now if you want, you can do it separately, or if you can do it together itself. So OA means x varies from 0 to a. And we have to write x square dx here. You have to focus here. Plus AB means y varies from 0 to b, and that is minus 2ay dy. Plus the third one, x varies from a to 0, and that function is x square plus b square times dx. Now that is simple integration. So the first one will be x cubed by 3 within the limits 0 to a, and the second one, it's going to be minus 2a and y squared by 2 within the limits y equal to 0 to b, so it's going to get cancelled, plus x cubed by 3 plus b square into x within the limits a to 0, and that will be a cubed by 3 and if you put the upper limit, okay, minus ab square and plus, when you put the upper limit, you're going to get 0 minus a cube by 3 minus b square into a. So the final answer is minus 2ab square. Now one more very important question of the same type, we will discuss that. So you can write the question. Evaluate the integral over c 3x minus 8y square times dx plus 4y minus 6xy times dy. So they have already calculated f dot dr. So we have to find the work done. And the path is given. C is the path bounded by the region. The boundary is given. X equal to 0, y equal to 0, and x plus y is equal to 1. So x equal to 0, y equal to 0, x plus y is equal to 1. Now look at this. X equal to 0 is the y-axis, y equal to 0 is the x-axis, and this is a line. And how do you know it's a line? Look at the power, look at the degree of x, that is 1. Look at the degree of y, that is 1. So definitely it's a line. And the best method to draw a line is put it in intercept form. And this is really easy. X by 1 plus y by 1 equal to 1. And always remember, to plot a line, you need minimum 2 points. Okay, that's it. We got 2 points. The x-intercept. That means the line will meet the x-axis at 1 and also the y-axis at 1. So there is our line. So this is our region. This is our path. This is C. So let's draw it properly. Okay, so this is our y equal to 0 and this one is x equal to 0 and this of course is x plus y is equal to 1. So it's very easy. Our path, let's give some names. O, A, B. So C means OA, what's the direction? Anti-clockwise. AB plus BO. In OA, y equal to 0, that means dy equal to 0 and x varies from 0 to 1. I hope you remember that intercept form. So this is actually 1 comma 0, or rather at this point x will be 1 and at this point y will be equal to 1. And you can write f dot dr or the integral a little bit later. And AB, you have to be very careful with AB. Look at this. We start from here. That means we start from x is equal to 1. And now I move like this. I hope you can see in that picture. And when I'm here, for the limits you should focus on the x-axis or on the y-axis for the limits of y. So when I'm here, you should focus on this point. And when I'm at the end, you should focus on this point. So the path is x plus y is equal to 1. And x varies from 1 to 0. I hope you got this point. X varies from, we have to move in counterclockwise direction. So we start x at 1 and we end up our x at 0. And you can find the differentials later. Now the last path, BO. I have written BC. Correct it. Yeah, BO is the y-axis. Y-axis means x equal to 0. So the differential of x will be equal to 0. And it's really easy. Y varies from 1 to 0. So we have the question here. So what we do is, we integrate. Integral over C is divided into 3 parts. So this is equal to integral OA. OA means x is going to change. X varies from 0 to 1. and you can see that y is equal to 0 and dy equal to 0. So this whole thing will vanish and this part. So we get 3x dx. In the next part, you have to be very careful. If you want, you can convert it into x or y as you wish. I'm going to change this into y. So it's like y also varies from, I didn't write the limits earlier, that also changes from 1 to 0. And then 3 into, what is x? Look at this, x plus y is 1, so x is equal to 1 minus y. So 3 into 1 minus y minus 8y square, and dx is equal to minus dy. So multiplied by minus dy, plus in the next bracket 4y minus 6 into y into x. What is x? Yeah, 1 minus y and dy, plus the last integral. In the last integral, y moves from 1 to 0. And the good news is x equal to 0, dx equal to 0. So the whole first term will disappear. And since x equal to 0, this part will also disappear. So you end up with 4y dy. And that's it. I'm sure you're very good with the basic integration. So integrate yourself. Make sure you integrate. And the final answer should turn out to be 5 by 3. So you can check whether you get 5 by 3 or not. Now let's move on to the next topic, and it's a little bit important for your exam, scalar potential. This is a exam preparation series, and within 1 or 2 weeks you'll have your exams. So we are just learning the outline or the process. I'm not going into the logic behind it or anything, but you have to know a few things. So we start with a vector function f. Point number 1, you find curl f, and if you get curl f is equal to 0, then you must understand work done is independent of the path. You can find the proof in your books, and in later videos we'll prove. First we'll complete this topic and we'll go for the proof, and sometimes in your question papers they ask proof. So be ready with all the proofs when you go for the exam. Sometimes there will be no numericals at all. So be ready with all sort of proofs. So remember, if curl of equal to 0, work done will be path independent. And I'm sure in physics you learned that work done against gravity is independent of the path. Because when you go up, it doesn't depend whether you move in an inclined manner or through a spiral staircase, or anyway at the topmost point you'll have that potential energy. That's all. You can refer the physics books for that. Anyway, so if curl of equal to 0, mathematically we have to understand work done is independent of the path. Okay, now point number 2. In such cases, you will be able to find a scalar function in such a way that you'll always be able to write f in terms of phi, and that will be f will be equal to gradient of phi. Yeah, the things which you learned in second semester, gradient, divergence, curl, etc. That is, you'll be able to write f is equal to del phi or nabla phi. Okay, so with this, let's start the lesson. So they will ask 2 types of questions in your exam. Sometimes they will ask you to prove that work done is path independent, the general proof of course. And when they ask numericals, they will ask you to prove that the field is irrotational. Irrotational means curl of equal to 0. That's what you learned in the last semester. And they will ask you to find the scalar potential. I'll repeat, they will ask you to find the scalar potential. That means you have to find the value of phi. And that is exactly what we are going to learn now. So let's check out some past year's question paper. So let's start with this question. It's from long back, 2068. Okay, so the question is, show that the vector field F is irrotational. I told you. It's the same thing they ask in your second semester. And another word they might use is, they will ask you, prove that the vector field is conservative. Conservative means path independent, and path independent means curl of will be equal to 0, and that means irrotational. So all you have to do is, you have to find curl F. And I hope you remember the formula for curl F. That is determinant I, J, K, and the partials. So partial with respect to x, partial with respect to y, partial with respect to z, and the coefficient of I. I guess it's not that hard to read. I'll read that for you. X square minus yz, y square minus zx, and z square minus xy. So just evaluate the determinant, just like you did in the last semester. So I into, so we have to do partial with respect to y. You have to do partial with respect to y for this function. That means y is the only variable. So it's going to be 0 minus x into 1. That is, you're going to get minus x minus. Now you have to differentiate partially with respect to z. That means z will be the only variable, and that will be 0 minus, okay, that will be minus x, and minus j. You remember how to expand a determinant, right? Plus, minus, plus. Yeah. Okay, now these are the basic stuff. I'll remove this for you. Yeah. Okay, now let's focus on these two. So to differentiate with respect to x, this function. So who is the only variable? X. And that will be 0 minus, minus y, and this thing with respect to z. As expected, we get minus y plus k, and this thing, it's already in a mess. So 0 minus minus z minus of minus z, as we expected, is equal to 0. That's it. So the vector field is irrotational. And what is another word? Conservative. So let's write like this. Therefore, our vector field is irrotational or conservative, or work done will be path independent. Okay, now they have asked, find the scalar function in such a way that f equal to del phi. And what does it mean, or what is it called? The scalar potential. In some question papers they will not explain. They will simply ask, hence find the scalar potential. So that means we have to find a function, a scalar function, in such a way that f will be equal to nabla phi. And that is, f is our given function, that is x square minus yz times I plus y square minus zx times j plus z square minus xy times k is equal to, I hope you remember the formula from the last semester, gradient of phi or del phi is given by I partial with respect to x plus j, the partial derivative of phi with respect to y, plus k, the partial derivative with respect to z. Now tell me, when will two vectors become equal? Yeah, when the coefficients of I are equal, j are equal, and that simply means we get the partial with respect to x to be x square minus yz, and partial with respect to y is equal to y square minus zx, and partial with respect to z to be z square minus xy. Okay, now comes the most important part. Book to book, they use different methods. Anyway, I'll tell you a method which I like, and I think that method is more student friendly. Okay, so look at this. I'll tell you the problem. We are trying to find phi. If you have the derivative, let's say you know d phi by dx is equal to x square, ordinary differentiation, not the partial derivative. If you have the derivative, you'll make this into a variable separable type. You'll just make it into variable separable, and you integrate, you will end up with phi. But things are not that easy here because we have the partial derivatives. But the good news is you have all the partial derivatives. And when you have all the partial derivatives, you will be able to find phi. So let's try that process. So now you know that the partial with respect to x is x square minus yz. And the partial with respect to y is equal to y square minus zx. And the partial with respect to z is x square minus z square minus xy. Now look at this. We are trying to find phi. And this method will work only if you have all the partial derivatives. Okay, now I am going to integrate. And remember, when you find partial derivative, you treat y and z as constants. So when you differentiate, so when you integrate, remember that fact. So we are going to integrate with respect to x. So I am going to get x cubed by 3 minus y into z into x, because integral of a constant with respect to x will be constant into x. And I told you I am integrating with respect to x. And when I integrate with respect to x, this is a constant, so I get constant into x. Plus, this is the most important point. You have to write a function in y and z. I'll tell you the reason. This is a partial derivative, and when you found the partial derivative with respect to x, you treated y and z to be constants. So when you integrate, you must write this, and also a plus c. That's ordinary constant. Now applying the same logic, we get y cubed by 3, and this time I am integrating with respect to y. So zx into y plus another function, but this function will be in terms of z and x, because when you found this partial derivative, you treated y as the only variable, or you are treating z and x to be constants. And the third possibility, phi is equal to z cubed by 3 minus x into y into z plus a function in x and y plus c. Okay, now look at this. What are you trying to find? We are trying to find Mr. Phi. We already found phi. 1, 2, 3. We found 3 times, but we don't have the answer. So if you want the answer, you should either find this phi 1 or phi 2 or phi 3. And for that, I have a trick. And I'm going to use the first one. So look at this. Phi is equal to, from the first equation, x cubed by 3 minus yz into x plus, okay, now I'm going to find phi 1. The specialty of phi 1 is there will be no x. It is a function completely in y and z. And all you have to do is you have to search all the values of phi. So I'm looking for a function or a term which is independent of x. Okay, this is not independent of x. This is not independent of x. This is independent of x. This is not independent of x. This is independent of x. This is not independent of x. And please remember, if a term repeats, don't take it more than once. So now look at this. Phi 1 means terms independent of x, terms which do not have x. So that will be y cube by 3 plus z cube by 3 plus c. That's it. That's 5. And that will be our scalar potential. Okay, now I know some of you understood a little bit and some others didn't understand anything at all. That's why we're going to do one more problem of the same type. So get ready with your pen and paper and let's start with another question. So this is from 2073 and it's the same thing. Show that the function is irrotational. Or what is another possibility? The work done is path independent. And what is the third possibility? Conservative field. Whatever they ask, you find curl f and prove that curl f is equal to 0. So here we go, I, j, k and the partial operators by dou y and z, and of course the coefficients of I, j and k. Okay, so let's find the determinant value. So you have to differentiate partially with respect to y. So I will get 1 plus 0 minus, I have to differentiate with respect to z, minus j times, I'll leave this with respect to x. So I'm going to get 2z minus 2z plus k into, that will be 0 minus 0. Anyway, the answer is 0. Okay, so that means the given function, the given vector function, the given vector field is conservative or irrotational, or work done in that field will be path independent. So we write, so look at the next question. Find its scalar potential. Unlike the previous question, they have not explained what to do. So finding the scalar potential means you have to find a scalar function phi. So we start like, let phi be the scalar potential. Therefore, f is equal to del phi or grad phi. And f is the given function, and that is 2x plus z square times I plus z into j plus y plus 2xz, and what is del phi? I partial with respect to x plus j partial with respect to y plus k partial with respect to z. And that implies we will be able to access all the partial derivatives. And since you are able to access all the partial derivatives, we will be able to find phi. So I'm going to write the next part. So the partial with respect to x, the partial with respect to y, and finally the partial with respect to z. So equating this and this, we get 2x plus z square, and this is equal to z, and the last one y plus 2xz. And now what should we do? Integrating with respect to x. So I'll get phi is equal to 2 into x square by 2, so 2 and 2 will get cancelled, plus this is a constant with respect to x, so z square into x, plus the most important thing, phi 1, a function in y and z, plus c. And from here we get phi is equal to, okay, we are integrating with respect to y and this is a constant, so z into y plus function in x and z plus c. And again, now we are going to integrate with respect to z, and this is a constant, so y into z plus, if I integrate with respect to z, this will be constant z square by 2, so I get x into z square plus the most important part, a function in x and y plus c. Now let's learn the trick once more. Look at this, we are trying to find phi. Actually we found phi again and again and again 3 times. But if you want to write the proper answer, we should find phi 1 or phi 2 or phi 3. So let's stick to phi 1. So I'm going to write the answer x square plus z square into x plus, wait a minute, we want all the terms independent of x. There should not be x. Okay, I'm going to start my search. This is depending on x, this is depending on x. Yeah, this does not depend on x. Okay, this does not depend on x, but it's the same thing. I told you not to take repetition. So I'm going to write zy exactly once. This one depends on x. That's it, plus c. So this is our scalar potential. So that is x square plus z square x plus zy. So there is another question that's from 2071. It's the same type. So prove that the vector field is conservative. So what are you going to do? You have to prove that the curl of the function is equal to 0. And this time I'm not going to do that. So I'll stick to the second part, the scalar potential. So find the scalar potential means first you prove that the field is irrotational or conservative or path independent, that is curl of equal to 0. So I want you to do that part, curl of equal to 0. And then what do? We say or we claim let phi be the scalar potential. Therefore f will be equal to del phi. And f means the given function, and the given function is y cube times I plus 3xy square plus e to the power 2z times j plus 2y e to the power 2z times k is equal to, what's the formula for gradient? Yeah, I del phi by del x plus j partial with respect to y plus k partial with respect to z. And that clearly implies you can access all the partial derivatives. And since you can access all the partial derivatives, you'll be able to find phi. So this is y cube and this part is 3xy square plus e to the power 2z, and the last one partial with respect to z is equal to 2y e to the power 2z. And I'll repeat once more, our aim is to find phi, and that is possible because we have access to all the partial derivatives. Okay, so I'll confirm this once more. Yeah, y cube 3xy square plus e power 2z and 2y e to the power z. So from the first one we get phi is equal to, look at this, we are integrating with respect to x and this is a constant. So y cube into x plus a function in y and z plus c. And from here we are integrating with respect to y. The first part is not a constant. So y cube by 3 plus, so that cancels. Yeah, now this is a constant into y plus a function in z and x plus c. And the last one, phi is equal to 2y is a constant, e to the power 2z by 2 plus a function in x and y plus c. Okay, that's it. Now we have found phi, but I'm trying to find phi 1 or phi 2 or phi 3. So our answer will be equal to y cube into x plus, we have to find the terms independent of x. So this depends on x, this depends on x. That means, yeah, we have to take this. So e to the power 2z into y. Okay, this is independent of x, but it's the same thing. we don't take repetitions, plus, yeah, that's it, plus C. Now I hope you understood the method properly. Anyway, you can test yourself. I'll give you one more question before I wind the video. So, I have one more question. It's from 2069. It's the same thing. So, try to work out this question now itself. So, I'm going to wind up this video right now. Soon, I'll be back with another video in which we will discuss Green's theorem, which is very important for the exam. So, till then, bye.